Before we get rolling, just for me to get familiar with my audience here, how many of you guys have a Tesla? Oh, wow. Look at that. No, the reason I bring it up is that I think it's almost every year or every 2 years we get the promise by the guy who promised to buy Twitter that we'll get self-driving cars, right? And it hasn't happened yet, and I'm not entirely confident it'll happen. But anyway, I digress. The reason I brought it up is that a couple of years ago, we were here at Storage Developer Conference. We were talking about making storage fabrics autonomous. And I'm here once again to say that we are making storage fabrics autonomous, and we are making progress toward getting there. Once again, as we kind of work through our material here, you'll see that we are not there yet. But we are making progress, and we'll provide you an update on what we are doing, where we are challenged, so to speak, in kind of making storage fabrics more intelligent, more autonomous. I'll provide some contrasting view. Could be contrasting to other speakers you have heard, probably in this room or larger rooms, about other fabrics. But so with that, let's get rolling. To introduce, my name is Nishant. I'm work on a bunch of different storage technologies at Marvell. With me, my partner in crime or whatever is Shyam. Shyam is a principal storage engineer in our group. He has climbing El Capitan as part of his bucket list, which I don't think I can even watch from the bottom. But again, I digress. With that, let's get rolling. We're going to break this into two pieces, right? I'm going to kind of put a little bit of my perspective on where do I think that storage fabrics, are they becoming intelligent or not? And I'm not talking about AI and ML and deep learning and all of that, just intelligent or not. Right? Are they being coded with intelligence that they need to survive out there in the wild, where conditions change? And then certainly I'll introduce a little bit about a recently ratified standard around fiber, which we call as fabric notifications. I know Howard here in the room has another session, which probably will talk about in more detail about those. But I'm here not to talk much about the standard, but more about our experiences implementing fabric notifications. Do they make are the storage fabric that we manage more intelligent? Are there challenges and stuff like that? And Shyam will come in, he'll talk in more detail about, because he's been the guy actually developing the code around all of this. So you'll get to hear from him in a little bit more detail. With that, let me get rolling. What I wanted to say, just put things in context here, right? We have heard in this room and many other places that there are a bunch of different fabrics. When people talk about fiber channel, I think there's more than one people who smiles, but goes back and supports a customer who is running fiber channel. So definitely, I would say that fiber channel, in my view, and I've spent off and on the last 10, 12 years kind of working on fiber channel connectivity and FICON and VI and many other things around this. I definitely see kind of business critical applications still sticking on to fiber channel for that matter. I also see that there is a transformation in place going to NVMe and NVMe over fiber channel, once again, providing concurrent access to both doing FC and NVMe as well as FCP. iSCSI, I definitely think there is a very strong alternative to iSCSI with NVMe over TCP. I see NVMe over Rocky V2 pretty much in the rearview mirror, so to speak. There's a lot of excitement in the early years about RDMA. I know this group was talking about how it transports over UDP, and I've kind of cut my teeth on trying to implement DCQCN, or data center quantized congestion notification. I've spent many sleepless nights trying to make it work effectively. Some have been able to work. For example, we heard Greg talk about in the Azure session that they use RDMA to run on top, direct drive to run on top of that. But certainly, Azure has the scale, and I'm not saying that people in this room are not smart enough, but they have the scale, the firepower, and the manpower to pull off something that complicated. If you throw enough money at a problem, you can solve even molecular and DNA storage, and this is Mickey Mouse stuff. Sorry. I hope we are not recording that, but moving on, we are also definitely, there are other alternatives to storage fabrics. Not everybody uses external storage. There's hyperconverged storage, pretty popular, fast growing, especially on the kind of edge side, low cost, hands-off kind of management with hyperconverged. I also see RDMA there, a little bit of IVAR from Chalcio, and then certainly Rocky V2 is also happening there. The point that I wanted to make after going through all of this long rant here is that all of these are going to survive into the future is my view of the world. I expect to see kind of fiber channel continue on with FC and VME, still continue to run on-prem business critical applications. There are a lot of people who are interested in backing up huge quantities of data on tapes, and fiber is a great choice for that. Not relevant to this or more of an NVMe conversation here, but we are transitioning from a heterogeneous world to another, but a lot of things are changing in that heterogeneous world. And I'm going to talk about some of those things and how that impacts the decisions we make to make our storage fabrics more intelligent. Before that, this is my and much contested view from others, both near and far from me, about how I see the different applications who have affinity towards the storage fabrics. We'll start here on the kind of fiber channel or FC and VME front. A lot of customers, business critical applications, large databases, high density VM farms rely on the high performance, the kind of air gap network that fiber provides, still continue to run their using external storage. Here on the extreme left is definitely kind of NVMe over Rocky V2. For all its scale challenges, sometimes cost and complexity related issues, the big thing that has been going on for NVMe over Rocky V2 is that a lot of the AI ML stacks, just from the time they were deployed or built in academia, used InfiniBand and Rocky V2. So there's a lot of kind of inherent, not just from a storage use cases, but there's a lot of inherent RDMA into Tensor and PyTorch and stuff like that, that enables extension of that for storage related fabrics. I also see kind of applications like Mongo and Cassandra who are more kind of DAS specific to extend DAS into what some people call as an Ethernet bunch of flash, to basically expand storage beyond the capacity of a server. But either if you are a Democrat or a Republican, you get a choice between fiber channel and Rocky V2. But if you are somewhere in the middle, like me, right, you have choices with something more generic, which is NVMe over TCP. Much has been spoken on NVMe over TCP in this conference alone, and I'm really excited to see the bunch of work happening around TCP, whether it is the CDCs, the DDCs, the zone controls and stuff like that. So a lot of good progress there. But this is how I see specialized use cases, high performance, small scale use cases pick up on NVMe over Rocky. I see business critical stuff running on fiber, and then everything else in between can likely significantly benefit from NVMe over TCP. Although one thing that, in my view, is not going in the favor of NVMe over TCP, a lot of work has been done in the standards to make it more efficient. There hasn't been enough kind of work or money thrown at to make TCP, to offload TCP down to some kind of device. Tow engines are hard to come by and hard to implement, and often contested on their quality, but that's something is eventually, when done in a smart NIC or somewhere, can significantly accelerate what NVMe over TCP value proposition has. But starting to talk about a little bit more about kind of intelligent fabrics. And before I get to my conversation with you guys about intelligent and autonomous fabric, I just wanted to set the stage. No customer wants just one thing. No customer wants just low latency from the fabric, other than those Robin Hoods who are selling my trade to somebody else to try to make a cent or two on it. The financial traders, but people want more than just one thing, right? And one of the biggest things, most important thing, nobody throws away infrastructure that's I've invested in, that's running, that's serving a purpose. Everybody wants to leverage an existing infrastructure. Ethernet is a great choice for that. That's why NVMe over TCP is being talked about. Last time I checked, less than 5% of the NICs that blink in your customers' data centers have RDMA capabilities. So That's one of the big things that's going against the kind of RDMA story, at least at a broader scale. A lot of fiber investments already around. Things around, I'll just quickly build this up into a couple of things. People expect operational simplicity. A lot of people want to do kind of more with less. They expect fabrics or storage devices to do things by themselves, so to speak. A lot of customers, I say, oh, this happened because of that path, that error happened, or congestion happened there in the fabric. Or if you knew about it, why didn't you take any action in your devices and our products? And sometimes these actions are difficult to take. A lot of times, we who have spent a lot of time in the storage world are conservative about our approach. We don't want to kind of rock the boat and take actions because, A, we have very huge install base and we risk doing something which is rather unknown and can have kind of other consequences. There's definitely conversations about consistent performance, not just performance, but consistent performance. A lot of people do benchmarks, and I used to do a lot of benchmarks, and we set up everything beautifully and in a nice, clean environment, run benchmarks, and everything looks good. And you ship that off to an customer, and the customer deploys it in pre-production. Everything looks really good there too. And that thing rolls out into production. A couple months go down, VMs move around, new devices are added, congestion happens, link goes bad, and all that beautiful performance charts you built earlier in your lab or in pre-production are down the drain, right? You have customers shouting, my boss shouting at me, and including my wife shouting at me because I'm working at the customers. Anyway, a lot of people shouting at me, right? But the lesson to be learned here is that we don't need to, we just can't build devices and intelligence in our devices to suit just our test environments or our customers' test environment. They need to adapt to real life conditions where things change, new devices are added, congestion happens, blah, 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 stuff like that. So not just about performance, but consistent performance. Security, I won't say a single word. Claudio said a lot of stuff, still resounds in this room. I can see the DHCHAP exchange still happening. And certainly reliability and open standards, right? No words need to be said there anymore to you guys. But all this stuff is important, but what about making fabrics more intelligent so that they can adapt to conditions that actually change in real life in a customer's deployment, right? In a customer's deployment that's been there for a couple of years, right? And the person who configured it and set it up is long gone working for some big cloud company, and rest leaves us the rest holding the bag, right? So a lot of work actually has happened in making fabrics more autonomous. In fact, I would classify a whole lot of work done from a day zero autonomous or automation perspective. People like all of us have kind of struggled with iSCSI and ISNS, and that thing kind of never took off. Nobody ever did it the right way, and there are a lot of people that I can list to blame, but today is not that day for that. NVMe TCP, I'm so glad a bunch of people, Eric, Dell people, other people in the industry have spent a lot of effort in doing CDCs and DDCs. I'm assuming all of you guys have heard about it. If not, you'll hear about it in the rest of the time today and tomorrow. But I still call this, and apologize for my language here, more Mickey Mouse stuff, right? It's day zero configuration, it's discovery, it's logging in. But what happens a couple months down the line when the stuff is running and there are other challenges? Can we do something that goes beyond day zero automation, day zero autonomous behavior, right? And I don't want to boast here about fiber. I mean, a lot of you guys have probably worked on fiber channel more than I have. But definitely Fiber Channel has all the kind of discovery services and login and all of that stuff works automatically. But there is other things that I have just two standards people here in this left-hand side table from me who have worked very hard to build a standard called Fabric Notifications for Fiber Channel. And that has helped us provide us a baseline in terms of a standard to actually try and solve some of the challenges that we see in real life when fabrics have been running for months, dealing with congestion, dealing with an extraordinary number of CRC errors that don't bring the link down, but still trouble the customer's application enough. Now that we have these kind of tools, we have in many ways struggled to put them to productive use. And that's the conversation here. And I'm just between for developers, by developers, an open conversation. And when I get to the end, I'll talk about kind of where we have succeeded and where we could still use some help. So just, I know a lot of you guys probably already know about Fabric notifications, but just a quick introduction before kind of Shyam goes in and talks in more detail about it. What is Fabric notification? It is a fiber channel standard. Like I said, basically it allows endpoints within a fiber channel SAN, which is comprised in hundreds and thousands of nodes, to tell each other about conditions that they see in the SAN in real time or close to real time, right? Like, it's not like somebody invented dynamite and kept them close to their chest for 100 years so the rest of the world did not come to know. This is about sharing information that we see, that endpoints, whether it is fiber channel switches, whether it's initiators or targets, when they see things going wrong in the fabric. And what can go wrong in the fabric? Starting from the top here, there is links that could start exhibiting errors. Hard errors are the easiest to solve, right? Right? I wish my boss assigned all the easily reproducible errors to me, but he assigns all the rarely reproducible error debugs to me, and then I always have a hard time trying to make that work because they are the most difficult things to solve. And similarly, the first item here is link integrity, which is there's a link that exhibits an extraordinary number of errors but does not go hard down. Right? And these errors happen in the fabric, and people can tell you a whole bunch of reasons. You know, in my attempt to clean SFPs, I have spat on them. Whether you acknowledge it or not, a lot of others people have also. And
so I was just going to say,
yes, please.
There's a software group that I'm dealing with that I'm trying to explain that this does happen out in the field. They have said that no, we just don't work on networks like that. The customer needs to get a good network.
Exactly. You know, what I say, closing your eyes doesn't make the problem go away, right? And next time, try telling that to a customer, right, who's buying millions of dollars worth of stuff for us. Who's right? The customer and my wife. Anyways, back to the topic here. So these link integrities happen. Anybody who sees errors in the link, they inform other parties, most importantly the initiators who is initiating. What can we do about it, right? We don't have robotic arms to go and clean the SFPs or those sticky material that helps clean the cables, but we can take alternate paths to get to our destination and inform an administrator that, hey, such a problem has happened. For now, temporarily, I've routed traffic to this other route so that your application keeps running, but better somebody look at it, right? But the challenge with a lot of these things are that the previous innovations in storage fabrics, or more specifically fiber channel, involved actions by a singular device, right? All those things, whether it was security, FC and VME, things like that. A device by itself could implement it, we could throw it out there and things would work. But decisions like taking another alternative path within a fiber channel SAN, when such a link error happens, requires broad scale integration with MPIO people, different operating systems. It requires a lot of convincing and a lot of buying people dinners to get to where you want to get to. It's not easy, and that's been a challenge, and we have made progress. There's definitely congestion. I can be the source of congestion, which often, if I'm getting late to getting back home, I'm the source of congestion on the freeway, changing lanes way too often. There could be other people who could be the source of congestion. What can we do when there is congestion in the fabric? And Shyam will kind of show you a picture on how actually congestion builds up in a fabric for all the things, like the person over there said, you know, these things happen, and you can't just ignore them and go away. One of the toughest things about congestion, and Shyam will certainly talk about it more, is that when it happens, it spreads in the fiber channel SAN. And once it has spread, it impacts many other devices. So by the time you come to know that there is impact of congestion in the SAN, there are already a lot of red hotspots, and there is no clear indication on where to go and start looking at. What is the root cause of the problem? Because the root cause is now started somewhere, it was not visible, now it is spread, now the red lights are flashing everywhere, and it's hard to tell. And finally here, last is kind of a delivery notification, which basically is a short circuit timeout where the fabric tells the transmitter that, hey, something that you sent out did not make it all the way. And we were just discussing back at work and here, this is kind of one tool in our arsenal about being notified about lost frames. that we haven't been able to, frankly, put to good use yet, right? That's something we have in the standards. We have the ability to register for it, to get it. But once I get it, what do I do with it is still some work in progress. So I think finally, in order to make storage fabrics more intelligent, more autonomous, to me, it starts with two things, right? A is become aware of the conditions of the fabric, which if somebody is sitting within a server, just an initiator, it is hard to become aware of what's going on in the world wide world. That's why we have newspapers that report information for all of us. And that's what fabric notifications do, is they report to all the endpoints so that they become aware of the conditions of the storage fabric. So that's the awareness piece. And then you have a decision. Once you are aware that something is going on, you can either try to fight it, try to reduce congestion, right? Or fly away, take another path through your destination in case of a link integrity. With all that theory said, what have we actually done, right? And certainly when I say we, I'm talking about the Marvell QLogic fiber channel HPAs, but this is not a chest thumping session. A lot of people in the fiber channel industry have implemented this stuff, so this is pretty kind of widespread. But starting here on the extreme left, like I said, it all starts with a strong awareness on what's going on. All our devices, and I can say that even for our competition's devices, that we do register with fiber channel switches, both from Brocade as well as from Cisco, to inform them that our HPAs are available and ready to receive these notifications. So when things go wrong in the fabric, when there is congestion, peer congestion, link errors, we would like to be informed. So the first big step of building strong awareness has already happened. We have rolled out. We see customers getting these notifications. That is the easy part. Easy because it was just our vendor's decision, right? People in the fiber channel industry who, hey, this is the right thing to do, let's do it. Now, what happens is that I do want to point out that there is kind of, think of it as software signals with the fabric notifications monitoring, and there is also hardware signals. Sometimes software signals can't reach their destination, so there is some hardware electrical also signals as part of the standards and implementation that allow us to get access to these notifications in very noisy environments. But having said that, think of an environment where there is a link that exhibiting a whole lot of CRC errors, but is still up and running, right? It is impacting application performance, but there is no hard down scenario. So multipathing algorithms won't take any action just yet. So we have to work with different MPIO subsystems to get them to accept a link integrity notification and then act on it as if it was a path down. Now, unfortunately, or maybe more fortunately today, that there are a few MPIO implementation or multipathing IO implementations. We have worked with the Linux community. Newer versions of Linux, the MPIO stacks have the ability to accept a link integrity event that is happening in the storage fabric routed through a fiber channel HPA all the way up to the stack, to inform them, and the MPIO stack will mark the path as degraded, right, and automatically route traffic through another route. So that is success. We worked with VMware, which is a big consumer base for fiber, and they have promised that they'll implement in their two multipathing algorithms, NMP and MPP, the ability to take alternative paths when there is challenges with link integrity. What happens when there is congestion? Right? When there is congestion, we can do a couple of things. Once again, the easy stuff is stuff that you control in your world, your household. Much easier to make decisions there than in the workplace, where there is a command chain structure, motivations, politics. I could go on, but that's not the topic here. There are actions that the HPA takes when there is congestion. For example, it does IO throttling. The HPA, the beauty is that initiator of the IO transactions, and when it sees that congestion is building up due to either its behavior, its bad behavior, or the behavior of other weaker components in the SAN, it actually throttles the IO down. It is today a conservative approach on throttling the IOs down because we don't want to impact the application performance. And once again, goes back to my comment, there's such a broad, multifaceted deployment of these fabrics that it's hard to take simple actions without risking potentially negative behavior out there. But There is other stuff that we can do collaboratively, and we are doing with the fiber channel switch people of a concept called virtual lanes. I think people call it virtual links, virtual lanes, and other similar names, which allow us to kind of create different virtual paths within a physical path, each one of them with their own credit mechanism that allow us to kind of quarantine different flows that are noisy or that are causing challenges in the SAN. With that said, I think it's time for me to pass it over to Shyam, and I think Shyam will kind of talk about his experiences implementing this, the challenges he has faced. And towards the end, I think what the most important part of this, if you hang around till the end, is the kind of the call to action or things that we could kind of leverage your combined potential and experience to help improve this. So over to Shyam.
Hey guys, I think we can skip over my content and directly go to questions. I think Nishant has covered most of what I had to say. But I think what I'd do is, rather than talking about the problems specifically, I'll talk about, I guess, based on everything that we know Fiber Channel already did, and the new challenges that evolve because of how the SAN evolves from day one of deployment. We'll talk about how the new standard around the fabric notifications could be used to address some of those issues and help the SAN administrator spend less time administrating the SAN. So when we had essentially a renewed look at what the problem is that we're trying to solve, and how we could actually take the SAN to be more autonomous, we really had to take a deep look at the current set of issues that the SAN administrators are getting pulled into when they are essentially dealing with the SAN environment. And based on our conversations with the customers, what we really learned is there are a few different categories of use cases that are, that are essentially making these problems show up, making them visible, and I guess it is some of these use cases which is making those problems hard to debug, hard to address. So I think Nishant already talked about how the SANs have become heterogeneous because of the pressures around CapEx and OpEx. The hardware utilization has to go up, which means workloads are moving around in the SAN. And that by itself causes pressure on the storage networks because of all the movement that is happening. But along with that, what happens is when issues, firstly, when there are failures in the SAN, they are extremely difficult to pinpoint because there's no single metric that the SAN administrator could look at to determine the health of the SAN. So what they are really going by is essentially waiting for the SAN performance in a particular configuration to dip beyond their expectations. And from that point on, they try to coalesce the information from the HPAs, the fabrics, the storage, put it together to actually understand what might have been causing the problem. Flash storage, while it is boon for all of us because of the speed with which the storage data can move, it has broken one fundamental assumption on which the SANs have been running, which is the storage is the slowest part in the environment. And essentially, as long as the fabrics and the hosts are tuned to accommodate for that, there would be no congestion. You put in a faster storage in that network, and now you've got storages which are pushing the SAN infrastructure to its limits, and the data that is honestly coming back from those storages, older generation of adapters cannot consume that data as fast as they're coming in. And I think beyond all of this, Nishant talked about how physical failures are fairly easy to deal with. If I've got a link down, it is fairly easy to detect and fairly easy to replace. But it is the aging process where issues start trickling slowly, and they essentially mount up to cause catastrophic errors. It is in this duration that the fault is difficult to determine, and if we think about it, if it is addressed at that point, we would never have to deal with those catastrophic events. So if we really kind of look at these problem statements, there are two broad categories of issues that the SAN administrators want us to address. The first thing is, if there are lingering issues, if there are timing issues, if there are isolated events of protocol level failures which have to do with physical infrastructure, the admins want to know about it early in the cycle so that they can go and replace it, they can go and plan for replacing it. That way their performance on the SAN is not impacted while it is operating critical workloads. The second thing is, with this workload migration, with how in the life cycle of a product, the upgrade cycles are going to be asynchronous. They want to make sure that we can do our best managing the conditions, moving traffic along the best we can in the environment that we have. So the next few slides, I'll take you through a bunch of conditions that we've determined the fabric notifications help us to determine early in the cycle, and where we could use those cues to essentially make better decisions to essentially keep the SAN operating as well as it can. Here's a simplified diagram of a SAN. We've got a couple of storage devices on the purple, the all-flash arrays, each one of them with redundant path connected to the switch. We've got a single host connected to the switch one with a couple of host bus adapters. Prior to the fabric notification coming in, if there was a link error, a CRC error detected on path 2 between the all-flash array and the fabric and the storage would be able to detect that, and they'll bump up their statistics around that error. But that notification didn't travel any further, which basically meant that from an administrator's point of view, unless he was looking for these issues on the switch and the fabric, he'd never come to know about it. On the front end, what really happened is, based on that error, possibly there would be a frame drop, and the IO request that was initiated by the application would time out, it would get retried, and everything would continue moving forward. The admin would only know about it when he was running a performance critical application here, and the performance dropped below a threshold that kind of kicked up alarms for them to become aware of it. With fabric notifications, what really changed here is, as soon as the switch to detects the link error, that information is sent to everyone, all the hosts that are zoned in to access that particular storage device. So what that does is, every single application which may potentially be operating with that storage would know that there has been a temporal link issue with one of the components in the path. And with that information, I guess at the host level, that information is made visible to the administrator. Along with that, I guess with the collaboration that we've had with our operating system partners, we're working on ensuring that, we also take corrective action as part of that, which is, the operating system multipathing layer can essentially use that information and look for alternative paths. And when that path is available, essentially move all the workload to that alternative path, which essentially can all happen automatically based on that single trigger from the fabric. In a similar manner, there are situations where a specific frame could be undelivered on a given path, and in the same mechanism, the notifications could be used by the host to retry that request, thereby essentially short-circuiting the amount of time that it takes to complete that request. Essentially, pre-FPINs, we would wait for the command to time out at the SCSI NVMe layer and then retry that request. But if the transport knows that a frame has been dropped, we know that this transaction is not going to complete. And so essentially the retries could be initiated sooner in the cycle to essentially have no downtime when it, or essentially no impact in terms of the error handlers kicking in. So these were the easier problems that Nishant talked about that we could solve just by the host becoming aware of that problem. Congestion, on the other hand, is something that really is multifaceted, right? Now, what complicates the matter is each of the link that we talk about, they are all bidirectional, which basically means that we have to deal with reads and writes going through every single intersection, and there is only so much that we can control from one end of the fabric. So this is an example of a SAN where day one or day zero, we had a single 16 gig storage array connected to a fabric serving 2 hosts. And at some point, a new 32 gig faster all-flash array was added to the SAN. Requests are initiated by both of the hosts. Host 1 is running traffic to the first storage. The host 2 is running traffic to the second storage. With data moving, the host sends RReady for every data packet that is incoming, and everyone is happy at this point. But with targets which are running at twice the link speed as the host, you essentially get into the situation where if you're running with faster targets which can really respond to data at the line rate, you now have 32 megabytes or 3200 megabytes worth of data coming out of this wire, whereas the host can only sync 1600 megabytes of data within a given second. So what happens to the balance 1600 megabytes? They essentially are stuck at the switch. And so that essentially puts a back pressure at the fabric. The fabric really cannot do anything with that data. Being fiber channel, the fabric cannot drop it. So it really has to hold on to all of that till the host is able to send more RReadies. Eventually, if that keeps up, the interswitch link gets backed up because the fabric on that side is unable to move any data, and that essentially ends up impacting the traffic between the host 1 and the array 1 because all that data was running through the ISL between these two switches. Now, pre-fabric notifications, this was almost invisible to the SAN administrator. He would only come to know about it after the host one essentially is running an application at lower than its capacity. And when he notices that notices the drop in performance, the first reaction is to assume that something is wrong with host one. But in this particular case, the host one really is not the culprit. He's just a victim of something that essentially started off because the host 2 was talking to a faster target, and he was not able to chew, I guess, he was biting more than he could chew. So, what essentially, with fabric notifications, what we are able to do, okay, I'll back off a bit. So, congestion is not something that, congestion is not a problem that is new. Congestion problems have, existed from the beginning of fiber channel deployments. And every vendor has been trying to solve that problem, to the best of their abilities in their devices. On the host side, I guess traditionally when we dealt with slower targets, the hosts implemented, a solution called IIDMA, wherein we essentially take into account the speed at which the target device is running, and we throttle down the amount of IOs that we send out to that particular target to ensure that the target is never overloaded. On the fabric side, we've essentially had solutions from Cisco and Brocade around called DIRL, SPDQ, port fencing, which were all mechanisms to essentially limit the exposure of the congestion and ensuring that we don't create too many victim flows. But because of the fact that if you think about the road systems, the fabrics could ensure that we had freeways where there were no traffic lights, traffic flew around without any issues. If we don't take into account that the surface roads don't, get into the freeways in a orderly fashion, you still are going to have bottlenecks at those connection points. And so what FPINs really helped with was, right when congestion started building up, and we essentially had sensors around that freeway that traffic was building, that information was pushed to the host, which was essentially driving most of that traffic into the fabric, into the SAN. And with that information, the host essentially could start throttling requests to a particular device. The hosts could alternately use virtual channels. So again, I think going back to the original or the current way of doing things, all we had is single lane TX and RX, and so data movement is always sequential. But I think with the introduction of virtual lanes, what we are able to do is, when we determine a set of endpoints causing congestion because of the disparity, we had the ability to now transfer some of those traffic into a separate lane, and ensuring that everything else can continue to operate in the normal lanes without getting affected. I think where we are getting to is, the host can control a lot of this unidirectional traffic. But when it comes to, I guess, addressing congestion bidirectionally, we need collaboration between all the endpoints in a way that, I guess, the same solution can be deployed on both ends of the SAN. I think, that's essentially all I had here to present. I think, I guess where we want to get to is, while the new standards help us, I guess, by improving our awareness of the SAN error conditions, the solutions that we probably can build and the mechanism that we can use to improve the overall SAN performance, has a lot of gaps at this point in time. And I think we are essentially looking at I guess improving our solutions along with working with partners to figure out how we can do a better job getting the SAN to essentially where we would like to.
Do you want to go to the next slide, Shyam?
Yes.
So I'll stand close to you so that we can both use the microphone. Apologies for the lack of shower this morning. But I just wanted to say that now that you've heard about all of this, heard about all the tools that we have access to, heard about what we have implemented, what we have been kind of somewhat challenged with, and where we have been successful, I would like to ask for a couple of things from you guys, okay? First, to start off from the very top is, now that you are aware, and if you, for example, build storage targets, right? Imagine if you could get these notifications, what would you do with them? So help me spread the word to your other colleagues, literally, or if you write code within your storage arrays or applications that actually can leverage these notifications. It's great. You have access to these coming into the HPA. Today they are being logged, showed in some kind of console. If you had access to them, what would you do with them? Similarly, for example, we talked about link integrity stuff. Today we pass it up to the MPIO stack, and the MPIO stack makes a decision. What happens if you were writing an application and the application had multiple different paths to its target, and now your application became aware of these conditions? Could you do something within your application to make it more available? So just, I ask here is to kind of think about these tool sets that are available to you, our experiences, and how you could leverage them. Another point that I wanted to make here was a kind of gap in the standards, and I don't mean to take a punch here at anybody about standards, but for example, most of our conversation was about the fiber channel switch, looking at conditions in the SAN, counting counters, having this great view, sitting on the top of a pedestal on where the traffic is moving around, and informing these tiny endpoints about what's going on, right? And the endpoints perhaps taking some action. We, within the endpoints, the initiator or the target, also have the ability to look at conditions around us and inform everybody else, right? We could look at potentially congestion, read side, write side congestion building up and inform others. We haven't done that yet. We just kind of explore the possibilities that this tiny endpoint, which doesn't have that broad a view of the fabric, if that were aware of congestion and informed others, what could we do with it? The other thing is, for example, we talked about the link integrity. Today, what happens is the switch, which has access to like millions of counters, looks at the rate of CRC errors. Let's say they go more than 10 a minute. I'm just picking a number here, right? If it goes for 10 a minute, it informs the endpoint that, hey, there is this link that is starting to exhibit bad things. So there's potential for bad things, right? Between the two kind of switch vendors implementation, there are different thresholds for each one of them. Some will inform you for 10 CRCs a minute, the other one would inform you for 25 CRCs happening in 2.5 minutes. So then if I, from an HPA perspective, was to make a decision from my view of the link as to what are the conditions that I should use to inform the rest of the world that the link is flaky, I'm challenged because there's no consistent view of what's wrong, what's right? I often tell my kids there's no right and wrong, there's only legal and illegal, right? The rest all is just perspective. But things are a little more complicated here, unfortunately. So we need kind of some understanding between us who participate in the fabric as to what is the bad link integrity, what is tolerable, what's not, depending upon choices and workloads and things like that. And finally, last I would say is, this stuff that we are talking about, this is not high in the sky, again, taking a pick at molecular and DNA storage. This stuff is implemented within our devices. You could use our GA code from the Marvell QLogic Fiber Channel HPAs, use Brocade or Cisco switches to hook up. Give them a shot. See how well our IO throttling algorithm works. See how well our virtual lanes work to segregate traffic. It's easy to simulate congestion in the SAN. There's kind of a bunch of nice white papers written around it. See if it is effective. Because the thing is, considering the huge install base of this, we alone cannot characterize and understand how well this stuff is going to work out in the wild, right? A lot of you guys have big customer base, a lot of experience. We have actions also implemented, like throttling, especially for congestion. They are disabled by default, and as we make progress into test driving this, getting your feedback, we want not just awareness, but automatic, by default, decisive action. That's all the stuff that I had to say. We can please questions, comments from any one of you guys. Yes, please.
When you do take action, do you run into
Oscillations,
oscillations?
yeah. Shyam, please.
Not necessarily. So the way this is set up is, the fabric would. So there are two kinds of events here, right? The delivery notifications, the link integrity events are single-time occurrences, right? So that information gets logged, we take our actions, and we move on. Congestion notifications definitely are something that are a lot more dynamic, and congestion could be something which is because of a specific configuration. For instance, you essentially have that slow target talking to a fast initiator, or vice versa, where oversubscription would be permanent. Congestion could be temporal, wherein you essentially have a bunch of initiators talking to the same target, causing oversubscription, or you have a single host talking to a bunch of target devices. All of them temporarily are sending the data at the same time, which is essentially causing backup, right? In both of these situations, the solution has been implemented in a way where there is enough interval between these notifications coming from the fabric that, so ultimately all we are trying to do is we are trying to ensure that there's no significant backup on any single point in the SAN. And so when the fabric notifies the hosts of congestion, the fabric is just saying that we've got a bunch of resources tied up in this particular IO path. Can you help us out on that, right? And so all we are trying to do from the host side is see if at that point in time, we can either move that specific set of traffic to a virtual lane, to a side lane, or if we can throttle the request down temporarily to essentially relieve that situation. When the throttling, when the congestion goes away, at this point, if the solution essentially just went back to running full throttle IOs, you will have, I guess, you will essentially have that ping pong. But instead of doing that, we take the approach of, gradually increasing the, IOs, wherein, think of, you driving on the freeway at 70, you essentially see a lot of traffic in front of you, you break down, you slow down, get to 35. From that point on, when the traffic relieves, you need not go to 70 from 35. You essentially could gradually ramp up to a point where you essentially can tell that you're at the same rate as the running traffic. And if that doesn't work out, you may have to slow down a bit. You may have to move further, faster a little bit. And so the algorithms are designed to kind of make that minute adjustments rather than making decisions to essentially move from, speed A to speed B, which is essentially pre-congestion.
I would add to that, from the switch, which has the view of congestion, you get notifications every 10 or 30 seconds. Maybe Howard will remember better, right? Which is frequent enough to kind of throttle up and throttle down to try and. So in our lab, we see kind of much steady IOs even when the throttling is going on. We are actually out of time. We can stop the recording and still keep talking.